Hi friends, in this video, we have to solve some questions of binomial distribution. The question is, a fair coin is tossed 5 times. First question is, find the probability of getting exactly 2 heads. Here, let x be the number of heads. Then, the probability of success is the probability of getting heads. We know that when a coin is tossed, the outcomes are head and tail. Thus, the total number of outcomes is two. Number of favorable outcome. Favorable outcome is the number of getting head is one. Therefore, the probability of getting an head is n of head divided by n of total number of outcomes equal to 1 by 2. Therefore, the probability of success equal to 1 by 2. Here given that a fair coin is tossed 5 times. Therefore, the number of trials is n equal to 5. Thus, the binomial probability distribution is P of x equal to x equal to n cx into p raised to x into 1 minus p whole raised to n minus x equal to, here n is 5, 5cx into probability of success is 1 by 2, 1 by 2 whole raised to x into 1 minus 1 by 2 whole raised to 5 minus x. Now we have to find out the probability of getting exactly 2 heads is calculated as P of x equal to 2 equal to 5c2 into 1 by 2 whole raised to 2 square into 1 minus 1 by 2 whole raised to 5 minus 2 equal to 5c2 is the 10 using calculator into 1 by 2 whole square is 0.25 into 1 minus 1 by 2 is 1 by 2 whole raised to 5 minus 2 equal to 3. Thus, 1 by 2 whole raised to 3 equal to 0.125 equal to 0.3125. Now, the next question is, find the probability of getting at least 3 heads. From the above solution, we get number of trials n equal to 5 and probability of getting a head equal to 1 by 2. Thus, the binomial probability distribution is P of x equal to 5cx into 1 by 2 whole raised to x into 1 minus 1 by 2 whole raised to 5 minus x. Now, the probability of getting at least 3 heads is P of x greater than or equal to 3 equal to P of x equal to 3 plus P of x equal to 4 plus P of x equal to 5 equal to 5c3 into 1 by 2 whole raised to 3 into 1 minus 1 by 2 whole raised to 5 minus 3 plus 5c4 into 1 by 2 whole raised to 4 into 1 minus 1 by 2 whole raised to 5 minus 4 plus P of x equal to 5 equal to 5c5 into 1 by 2 whole raised to 5 into 1 minus 1 by 2 whole raised to 5 minus 5 equal to 5c3 is 10 into 1 by 2 whole cube equal to 0.125 into 1 minus 1 by 2 whole raised to 2 equal to 0.25 plus 5 into 1 by 2 whole raised to 4 is 0.0625 into 1 minus 1 by 2 whole raised to 1 is 0.5 plus 5c5 equal to 1 into 1 by 2 whole raised to 5 is 0.03125 into 1 minus 1 by 2 whole raised to 0 equal to 1. Thus, 10 into 0.125 into 0.25 equal to 0.3125 plus 5 into 0.0625 into 0.5 equal to 0.15625 plus 1 into 0.03125 into 1 is 0.03125 equal to 0.5. Therefore, the probability of getting at least 3 heads is 0.5. Now, next question is, find the probability that head appears an even number of times. We know that x be the number of heads. Then x must be the even number. Thus, x have values 2, 4. The even numbers from 0, 1, 2, 3, 4, 5 is 2 and 4. From the above problem, we got number of trials equal to 5 and probability of success equal to 1 by 2. Thus, the binomial probability distribution is P of x equal to x equal to 5cx into 1 by 2 whole raised to x into 1 minus 1 by 2 whole raised to 5 minus x. Then the probability of head appears and even number of times is P of x equal to 2 or 4 equal to P of x equal to 2 plus P of x equal to 4 equal to 5c2 into 1 by 2 whole square into 1 minus 1 by 2 whole raised to 5 minus 2 plus 5c4 into 1 by 2 whole raised to 4 into 1 minus 1 by 2 whole raised to 5 minus 4 equal to 5c2 is 10 into 1 by 2 whole square is 0.25 into 1 minus 1 by 2 whole raised to 5 minus 2 is 0.125 plus 5c4 is 5 into 1 by 2 whole raised to 4 is 0.0625 into 1 minus 1 by 2 whole raised to 5 minus 4 is 0.5 equal to 10 into 0.25 into 0.125 is 0.3125 plus 5 into 0.0625 into 0.5 is 0.15625 equal to 0.46875. The question is, find the probability of getting exactly 2 tails. In the previous 3 questions, the number of success is number of getting heads. Here, the number of success is the number of tails. So, x be the number of tails. Then, the probability of getting a tail is P equal to 1 by 2 because there is only 2 outcomes when a coin is tossed, that is head and tail, and the probability of getting a tail from those 2 outcomes is 1 by 2. Then the number of trials, that is the number of times a coin is tossed is n equal to 5. Thus the probability distribution is P of x equal to x equal to 5cx into 1 by 2 whole raised to x into 1 minus 1 by 2 whole raised to 5 minus x. Then the probability of getting exactly 2 tails is P of x equal to 2 equal to 5c2 into 1 by 2 whole square into 1 minus 1 by 2 raised to 5 minus 2 equal to 5c2 is 10 into 1 by 2 whole square is 0.25 into 1 minus 1 by 2 whole raised to 5 minus 2 is 0.125 equal to 0.3125. The next question is find the probability of getting at most 2 heads. From the above solution, number of trials equal to 5 and probability of getting a tail is 1 by 2. The binomial probability distribution is P of x equal to 5cx into 1 by 2 whole raised to x into 1 minus 1 by 2 whole raised to 5 minus x. Then the probability of getting at most 2 heads is P of x less than or equal to 2 equal to P of x equal to 0 plus P of x equal to 1 plus P of x equal to 2 equal to 5c0 into 0 1 by 2 whole raised to 0 into 1 minus 1 by 2 whole raised to 5 minus 0 plus 5c1 into 1 by 2 whole raised to 1 into 1 minus 1 by 2 whole raised to 5 minus 1 plus 5c2 into 1 by 2 whole square into 1 minus 1 by 2 whole raised to 5 minus 2 equal to 5c0 into 1 by 2 whole raised to 0 into 1 minus 1 by 2 whole raised to 5 minus 0 is 0.03125 equal to 5c1 into 1 by 2 whole raised to 1 into 1 minus 1 by 2 whole raised to 5 minus 1 is 0.15625 plus 5c2 into 1 by 2 whole square into 1 minus 1 by 2 whole raised to 5 minus 2 is 0.3125 equal to 0.5. The last question of the given example is find the probability of tail appears an odd number of times. Here x be the number of tails. Then x have the values 1, 3 and 5. Since 1, 3 and 5 are the odd numbers between 0 and 5. From the previous examples, the number of trials is n equal to 5 and probability of success, that is probability of getting a tail is 1 by 2. Thus, the binomial probability distribution is P of x equal to 5cx into 1 by 2 whole raised to x into 1 minus 1 by 2 whole raised to 5 minus x. Thus, the probability of tail appears an odd number of times is P of x equal to 1 or 3 or 5 equal to P of x equal to 1 plus P of x equal to 3 plus P of x equal to 5 equal to 5C1 into 1 by 2 whole raised to 1 into 1 minus 1 by 2 whole raised to 5 minus 1 plus 5C3 into 1 by 2 whole raised to 3 into 1 minus 1 by 2 whole raised to 5 minus 3 plus 5C5 into 1 by 2 whole raised to 5 into 1 minus 1 by 2 whole raised to 5 minus 5 equal to 5C1 is 5 into 1 by 2 whole raised to 1 is 0.5 into 1 minus 1 by 2 whole raised to 4 is 0.0625 plus 5C3 is 10 into 1 by 2 whole raised to 3 equal to 0.125 into 1 minus 1 by 2 whole raised to 2 is 0.25 plus 5C5 is 1 into 1 by 2 whole raised to 5 is 0.03125 into 1 minus 1 by 2 whole raised to 0 is 1 equal to 5 into 0.5 into 0.0625 is 0.15625 plus 10 into 0.125 into 0.25 is 0.3125 plus 1 into 0.03125 into 1 is 0.03125 equal to 0.5. Thank you.